Hi guys, today's video notes are on 9.4a, graphing sine and cosine. And we're just going to introduce the parent function of sine and cosine today and talk about some key characteristics of the sine and cosine graph that will be helpful as we move into graphing more difficult transformations. So the first thing we're going to do is remember that a unit circle has a radius of 1 and sine is y values since opposite is y, and then hypotenuse is always 1, right? So you don't need to write 1. Cosine is x values. That means I can come down here and just label all of my sines. These are going to be y values, and these are going to be x values. Now you'll notice that I've given you some radians already. And notice that we're counting by 90 degrees. From 0 to pi is 180, so this is 90. Right? So this is 90 degrees, this is 180, 270, and 360. And this is just negatives going down. So let's take a moment and label our points. At this point, I have 1, 0. Because from 0, 0, I'm traveling a radius of 1, and I'm not moving up and down. So that means my sine for this point should be my y value, which is 0. Okay, I'm going to keep traveling and just do all of my sine points first. So then here, this point is 0, 1. This one is -1, 0. And this point is 0, -1. Okay, so I'm just going to travel and get all of my y values. My next one is 1, 0, -1, back to 0. And if we keep going, it's just going to continue in this pattern, 1, 0, -1, 0. So let's go backwards now. If I come down this way to -90, that's -1, back to 0, +1, back to 0. And this is a circular function, right, because it keeps going in this circle. And we can now plot our points. 0, 0, pi over 2, 1. Pi over 2, 1. And then I will have back to 0, pi, 0, down to -1, and back to 0. And then we know this one is going to keep going up. Okay. Here, let's graph this way. We're going to go down first, back to 0, up to +1, and then back to 0. And so what will it actually look like? Well, if we now think about pi over 4, that's this one. Those points are root 2 over 2 and root 2 over 2. Right? And if I do root 2 over 2 on a calculator, that's 0.707, I believe. So if I were to graph halfway, then this is going to be a 0.7 up here. You could almost say that the distance here, right, should be close to what we've got up here. So it's really a circle, like a half circle. And when we come down this way, it's another half circle, correct? Because if I have a pi over 6 here, it's going to be 1/2. So that's going to be right here, 1/2 pi over 6. So do you see how like we're really taking these points and we're translating them onto 1, 2, 3? Those 3 points are going to be here on this circle, and they're going to be here on this circle. And so when we graph this, it's going to be a circle on top, a circle on the bottom, right? And over here, we'll have a circle on the bottom and a circle on top. And it will keep going forever. So let's do the same with cosine right now. So we'll take a look and start at 0, 0. And that's this one, and we're going to do the x values now. So now our x is 1. We'll travel here. It's going to be 0, -1, 0, and 1. If we go backwards, it'll be 1, 0, -1, 0, back to 1. So those numbers look exactly the same. If anything, the pattern repeats. You see how they all repeat? And it's just shifted over by 90 degrees. Well, let's plot them. So I know I'm hitting 1, 0, negative 1, 0, 1. So I'm going to hit 1, 0, negative 1, back to 0, and 1. And so now this is the exact same pattern. It's still a circular function. Just shifted. Okay, so let's talk about some more information now. We know that each of these will continue forever and ever, right? We can go around the circle forever. And so domain is all real numbers. And range goes from negative 1 to positive 1. They can equal negative 1 and positive 1. My amplitude, this is a new vocabulary word. The amplitude is going to be a very specific piece of this graph, and the amplitude is half the distance from your highest point to your lowest point. Oh, max minus min. Another way you can think of it is the distance from the midline. I see how there's like a line in the middle here to the max or min. Since we're talking about distance, it's always positive. Okay. So really, where does this show up on your graph? Well, the amplitude is here. Okay, so if we talk about like our whole from the max to the min, we're going to take the whole thing, but we're going to cut it in half. So here's our amplitude and another amplitude. Okay. Right now on our parent function, the amplitude is 1. So now let's talk about the horizontal distance. That's our vertical distance. Eventually we'll be stretching it. Each function is periodic, which means that its graph has a repeating pattern, right? So the shortest repeating portion of a graph is called a cycle. And the horizontal length, or the x distance of each cycle, is called the period. So on a graph, that's basically the part of the graph that repeats over and over. So if you guys can imagine, it's going to be going around the circle one time, right? Do you see how I can take this piece right here that goes half circle up and half circle down, and then I can take that and repeat it and repeat it and repeat it over and over. Okay. Here we start at 1. Do you guys see how like this piece right here, that like little, I don't know, like a weird U, that piece also repeats right here, and I can take that little chunk and repeat it over and over, and that's also called a period. Well, it makes sense that the period of a circular function is basically 2 pi, because after 2 pi I'm going to go repeating again and again around the same points in a circle. Okay, the last 2 things you need to know is that there are multiple x-intercepts, and these are going to be really important later. So the x-intercepts for sine happen at whole number pi's. You see it has 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. And it goes on and on forever. It also happens the same negative. For cosine, it happens when we're at pi over 2's, right? So pi over 2, 3 pi over 2, 5 pi over 2. There isn't 4 pi over 2 because that's this one, and it reduces to a whole number. Okay? So before you close out the video, just make sure that you know that sine functions start at 0, 0. Cosine functions start at 1. I should say 0, 1. Okay? They're the exact same thing, but they shift. You need to know amplitude, and the period is 2 pi to start. Amplitude is 1 to start. Okay? That concludes our lesson for today. We will continue the next day with graphs that shift and transform our functions more.